Now we will discuss about the distribution of the different categories of the fluid in different compartments of the body. Definitely, if you give 1 liter of normal saline, it will be distributed in a different way. If you give 1 liter of the 5% dextrose, it will be distributed in the different way. And if you give the 1 liter albumin, it will be distributed in the different way. So the question arises here that if you give the 1000 ml of the normal saline, how much intravascular volume it will increase? This question is totally logical, as the normal saline, it contains sodium 154 and chloride 154, and if you sum them up, it will become 308, which is almost equal to the osmolarity of your blood. So basically sodium, it's the extracellular cation. So the sodium chloride, definitely it's a normal saline, it will be distributed into the extracellular fluid, and according to the fluid distribution, according to the criteria of the 2/3 1/3, we will divide the normal saline into two categories. We will divide the normal saline into the two categories that 2/3 will be distributed into the interstitium and 1/3 it will go into the intravascular volume. So now, according to the rules of the fluid distribution, we are doing this, and you can clearly say that from the 1 liter, that's the 1000 ml, 2/3 is distributed into the interstitium and 1/3 into the intravascular compartment. Now I am writing the 1000 ml, and if you calculate the 2/3, it will become 660 ml. It will go into the interstitium, and the rest 330 ml, it will go into the intravascular volume. So in the same way, if the 1 liter of the albumin, I means to say that colloid, it might be albumin, it might be hetastarch, it might be FFPs, it might be Mexil, which is the most commonly used fluid in our trauma and emergency. Then how much intravascular volume it will rise? It's very logical that they contain the bigger molecules. They will stay there into the blood. So they will increase the volume of 1 liter of the intravascular volume. That's 100%. It's very logical. It will not leak from your blood into the interstitium. It will be totally distributed into the intravascular component. So 1 liter albumin, it increases the intravascular volume by the 1 liter. In the same way, at this point I must tell you that 1 liter of the colloids is equal to the 3 liter of the crystalloids when there is talk about rise in the intravascular volume. Now moving on further, I will again tell you about the distribution of the 5% dextrose water into the various components of the body. You might be amazing that if you give the 1 liter of the 5% dextrose water, only 110 ml it will go into the, it will rise the intravascular volume. It seems awkward, but I am proving this, that you must be knowing that dextrose, when it goes into the body, it will be metabolized by the cell, and the rest pure water will be remained. And the pure water distribution, in the very start of my previous lecture, I have told you that according to the formula of 2/3 1/3, 2/3 it will go into the intracellular and rest 1/3 extracellular, which is further divided into two categories: interstitial 2/3 and the intravascular 1/3. So 660 ml it will directly go into the cells, and the 330 ml it remains, and from the 330 ml 2/3 it comes out to be the 220 ml, which will be distributed in the interstitium, and the 1/3 which comes out to be the 110, it will remain in the intravascular volume. So from the 1 liter 5% dextrose, the volume of the intravascular fluid, it will rise by only 110. Now I think you might have understood this thing, and it's all clear. That's it. In the further, now the question arises, if the maintenance fluid comes out to be the 3 liter, which fluid you will give to the patient? It's logical. The regimen one is that you will give 1 liter normal saline and 2 liter of the 5% dextrose. Why? Because normal saline, it contains 154 sodium, 154 chloride, and the osmolarity, it comes out to be the 308, which is equal to the osmolarity of the blood. And you will give 5% dextrose also, which don't contain sodium, potassium and chloride, all the things, and the osmolarity will be maintained. And in each drip you will add 1 ampule of the KCl, which equals to the 20 millimole, and the daily requirement of the 60 millimole, it will be fulfilled. And if somebody wants to give the 3 liter normal saline as a maintenance fluid, you will not give this. It will become hyperosmolar. So it's not logical. It's not logical. It's not logical. So you must take all the precautionary measures while giving the fluid, so that a patient might not go into the fluid overload or fluid deficit. 3 liter 5% dextrose water, you will not give this, because it does not contain sodium and osmolarity will not be maintained.